Okay, so hello everyone. Welcome back to the Python for Data Science course, the tutorial 4. And today is the last week. This will be the concluding week where we'll be completed with the course, whatever is our goal and whatever we wanted to teach with, we wanted that you learn. Okay, so so as you already know about all of the details by now, but as today is the last class and as far as norms and regular routine, I will again mention few things which you need to know that one thing is that whoever is unable to join this live sessions, please don't be panic or no need to be worried. You will be able to get all of these recorded session in the YouTube channel. The YouTube channel is shared here with you in the chat box. I have pinned it also, and there you can visit, and the things will be uploaded there, the recorded lectures, and the Google, and the slides and codes whatever I am using, those things will be shared. Those things are already shared with you via a Google Drive folder, and that Google Drive folder I have already given in the chat box, and you are also aware of. And of course, in the SWAM portal by NPTEL is also has also shared the things with you. So, okay, you can visit the YouTube channel and the Google Drive folder for all of the materials. And I hope everyone is able to access the files and play with them, and also the questions and the assignments whatever I have done till now, we used to whatever we used to discuss here in these discussion sessions, everything is uploaded and present, everything is shared with you. Okay, so welcome back again for the last time in this semester for this Python for Data Science course. And the first week was very slow, second week was a bit faster, and third week was very fast and with lot of information and lot of syllabus that I had to cover. So I hope everyone were like able to grasp them, and as well as everyone has practiced them. And as I encourage every time, this time also I will encourage that please use your, like today I will not do that kind of tutorial session that I will write one line of code and you will write and that line of code. It will not be like that, because I am assuming that now you are aware about Python. So today is the last day, and it is about a bit this is a bit involving, like we'll discuss about the data science, how to do the case studies and all of those things. Mainly it will be by verbally I will mention many things, and I will show some of the exemplary codes which which will help you to understand and get the clear idea about how to do the case study classification problems and all of those things. Okay, so be very patient and attentive towards this, and I will of course show several codes, and that will help you to learn and grasp the subject matter of this. Okay, so I will share, I will, and codes I will also share. And I have also prepared with the codes I have also given you the the text also, which I will like that you go through, and which I will tell here in the live session also. Okay, so so the thing is, what are the syllabus for this week is mainly the regression, that predicting price, like one example kind of predicting price of pre-owned cars, and so on. There can be like infinite number of options and examples in regression. And classification, like classifying personal income is one of the example, and there can be infinite number of options. So these two slides which were already shown in your lecture, but I would like to just I will maybe I will come back to it when come back again to with it when I will be done with the other part. But I hope that you have gone through these lectures and you know what we are going to discuss today about, because today is not about plotting and not about learning some particular thing. It is about learning something more. It is like the first step towards learning all of the machine learning, neural networks, and all of those kind of things. Okay. So this framework of the case study was given by professor in the lecture, which I will just go through just to remember, such that you can remember the things. But I will be very precise and in the very point wise manner I will tell you what are the steps that you need to follow to do these kind of things. Okay. So first in the concept, first you need to conceptualize the solution and identify the data is clean and look for the missing values. This part, these things which I am telling and showing in the slide now, that is already discussed with you by in the lectures, but still let me just go through this. And then you need to identify the variable influencing if you are talking about income status of the if you are dealing with any classification of income data and all those, then you need to identify the variables of influencing salary status and look for possible relationship between variables, that you can do by plotting various kind of correlation and plotting various kind of plots and by calculating the correlations, which I have discussed in detail in the previous class. Okay. Then you can do the identification of the categories that can be combined and build a model with reduced number of variables. So this is a very superficial way of telling that what we are going to do, but I will be very precise and tell you what you exactly need to do. Okay. That I will come. And after these things this is again the same thing for the one is for the uh, like like for the regression and the classification, you need to have the same kind of framework is needed, but there is some fundamental difference that I will also tell you. Okay, so first thing is that now, like that learning about machine learning and the classification, all of these things are very needed in modern days. Like nowadays, many industries have been dealing with very large data sets of different types. Manually processing all those data information is overwhelming and time consuming as well. And it is not, it might not even add any extra value in the longer term. So many strategies from simple automation to machine learning techniques are being applied for a better return on various kind of investment for various kind of industries. Okay. And this conceptual thing in this case the most important concepts that we would like to focus in this fourth week as well as in this course is mainly the classification and the regression. Okay, so we will start by defining that what is a classification is in machine learning before clarifying the two types of learners in machine learning and the difference between classification and regression. Okay. And then we will go some real world scenarios. I will show you some data and all of those things and apart from that I will show you some small examples so that you can grasp the idea totally. So classification is a supervised machine learning method where the model tries to predict the correct level of a given input data. In classification, the model is fully trained using the training data and then it is evaluated on the basis of test data before being used to perform prediction on new unseen data. For instance, a algorithm can learn to predict whether a given email is spam or not a spam. Okay. Oh, fine. So so there are two types of learners in machine learning classification. One is lazy learner and another is the eager learners. In eager learners, machine learning algorithms that first build in case of eager learners, the machine learning algorithms that first build a model from the training dataset before making any prediction on future datasets, that I was just telling about. They spend more time during the training process because of their eagerness to have a better generalization during the training from learning different parameters, but they require less time to make predictions. And most important, machine learning algorithms are eager learners. For example, logistic regression. There are some other like support vector machine, then the decision trees, then artificial neural networks. Okay, and there are lazy learners on the which is on the other hand, which do not create any model immediately from the training data, and this is where the lazy aspects come from. They just remember how that this is a very silly very nice way to remember eager learner and lazy learner. Okay, and in case of this lazy learner, they do not create any model immediately from the training data, and this is where the lazy aspects come from, and they just memorize the training data, and each time there is a need to make a prediction, they search for the nearest neighbor from the whole training data, which makes them very slow during the prediction. And k nearest neighbor and KR based reasoning, these are two lazy learner method. Okay. So, with all of these machine learning techniques, like whatever you are doing logistic regression or k nearest neighbor or artificial neural networks, the main goal is to do only the prediction, like which data you don't like you do not have some data, you have some test data, but you will immediately predict the thing just by your previously known data, by your training data. Okay, so that's why that's what's the aim for everything, but something is good for some cases and some other methods are good for some other cases. Okay, but of course the logistic regression, artificial neural network, decision trees, support vector machine, these eager learners are very swift and very they require much time to be trained, but they are much better in predicting the scenarios. There are four main categories of machine learning algorithms. One is supervised, second is unsupervised, third is semi supervised, and fourth is reinforcement learning. Okay. Even though classification and regression are both from the category of supervised learning, which is our focus in this class today, but they are not the same. Please be careful and carefully listen to this, that even though the classification and regression both are from the same category, that is supervised learning, but they are not the same. Why? Because the prediction task in the classification is when the target variable is discrete, and application is the identification of the underlying sentiment of a piece of text. That can be an example. And the prediction task in the regression is when the target variable is continuous. An example can be prediction of salary of a person given their education degree, previous work experience, graphical location. I mean, you can understand what is the discrete and what is the continuous. Okay, this continuous thing is that it can continue, it will continuously change, like suppose a salary of a person from in the first 5 years he has some salary on the basis of DATA and any other thing, in the after that in the next 5 years the salary growth will be there. So you need to consider in the regression model, also consider those things, that even you can think about the in stock market or the because it is also very continuous, it is like continuously changing depending upon the market. Okay, so so there is something continuously changing, which are for those kind of variables regression is good. Okay, so if you are interested in knowing more about classification, then of course you need to learn this supervised learning technique with the with the with this like whatever we sklearn, whatever we are will use in the Python. There are several data actually which are already real data that is provided without any that is provided to all of the Python users, and you can directly utilize those data to learn about this. Like I will show about two data, one is the IRIS data and another is the Boston data. Those are like available in the like common domain. Anyone can use this, and Python has supplied this to every users just to learn the data science and using the data, I mean which are based on the real world. Okay. So now you understand that there are four types of machine learning algorithm, which is supervised, unsupervised, semi-supervised, reinforcement learning, and in this case classification and regression, which is our goal. Both of them are supervised learning. Now there are four main classification. Okay, now I am talking about there are four main classification task in machine learning, which is already taught in the class also, but let me explain this, that what are those. Please you can take a note also with these things what I have just mentioned. That first thing is that there are four main categories of machine learning algorithm. In them, supervised in one, and classification and regression both are supervised learning. Okay. Now I am telling that there are four main classification tasks in machine learning, which these are the four main classification tasks. We be attentive with the words, that these are, now I am talking about four main classification tasks, which are binary classification, multi-class classification, multi-level classification, and imbalanced classification. The binary classification task is the goal is to classify the input data into two mutually exclusive categories. The training data in such a situation is labeled in a binary format, true and false, like this, positive or negative, 0, 1, spam, not spam, etc., depending on this problem being tackled. So these kind of problems are called binary classification. Multi-class classification is sorry, let me tell one more thing, that this logistic regression and support vector mechanics support vector machines algorithm are natively designed for binary classification. Okay. On the other hand, the algorithms like k-nearest neighbor and decision trees, which you have already learned, those can also be used for the binary classification. Now the multi-class classification. The multi-class classification, on the other hand, has at least two mutually exclusive class levels. Okay. So, so the thing is that the multi-class classification, on the other hand, has at least two mutually exclusive class levels, where the goal is to predict to which class a given input example belongs to. In the following case, in the following case means I can tell about that if you have a truck, a plane, and a boat. Okay. Now you need to identify for them that which was in plane. Then it can just pick that one out, that this is a plane. Okay. In case of binary classification, you have only a truck and boat, and it will just only from the two things only it will be able to classify. That's why it was binary. Now in case of multi-class classification, random forest, naive Bayes, k nearest neighbor, gradient boosting, logistic regression, these can be used. Okay. Now this multi-class can also be like multi-class can also be one versus one as well as a one versus others. Both way it can work. Now coming to the next, that is a multi-level classification. In multi-level classification, we try to predict more than one, more than two, like several classes for each input example. Like it cannot, in the other two cases it was like both are from the same genre, like truck and plane are from the same genre. But in case of multi-level classification, it need not be the same genre, it can be something else also. Okay, maybe a human, maybe a flower, it can also classify between the different levels. Okay, and such a scenario can be observed in most of the cases. Okay, uh, so uh, and there can be multi-level decision trees, gradient boosting, random forest, this can be used. And there is another thing, that is the imbalance classification, where there is a, which is a probability based characterization, classification or characterization. Okay, there maybe choosing you have truck, plane, boats, but there are several amounts of trucks, several amount of planes and boats, and each one probability to pick one boat or one plane from all of them is not just one or two. It can be like 60, in the 60% case you will pick up a plane or boat. That kind of probabilistic nature, when it come into a data, that is called the imbalance classification. Okay, so this is these are the things that that you need to know, those I wanted to discuss before starting the class, because this kind of classification question, the question means literally question with 4 different options, can come in the examination. Okay, so now I will go to the main thing, that is that I want to show you today, with the simple examples and all. I will go there. I hope everyone can see. Okay, so you can see that I have already given all the text which I am going to use at this moment. I will not I will go through this very simple, very steadily. You also go through this, that you will be able to understand what are the problems, what I was telling. And for particularly in this course, we are mostly bothered about classification. All the other things which I told, all of these all of these different techniques of the machine learning, those are not those in this course I just wanted to give the glimpse of all of them, but those are not all of the methods we are not going to discuss. Okay, so mainly we are going to discuss about this case study in data science and in that case we will be mostly talking about the classification. Okay, so and classification is a supervised machine learning. I have already given a lot of introduction about these till now. Now we can see that it is written that classification is a supervised machine learning technique or task that involves assigning predefined levels or categories to input data based on its features. The goal is to build a model that learns the patterns in the data and can accurately predict the level or category of new unseen data. It is commonly used for tasks like spam mail detection, disease diagnosis, sentiment analysis, image recognition, and much more, which examples I was also just telling in the few times ago. Okay. So, let us go through one simple case study to understand classification better. Suppose you had your case study is that simplest one, the email spam detection. So, the problem statement you need to understand first very nicely. So, you work for an email service provider and want to develop an automated system that can classify incoming emails as either spam or not spam, which we call as ham. Now, you have a data set of emails each labeled as spam or ham, which you already have, okay, along with the text contents of the email. Now, what steps you need to you need to done? So, you need to the first thing is that gather a labeled data set of emails where each email is labeled as spam or ham. You have already the data. Okay. Process the text data by removing the special characters, converting to lower case and tokenizing the text into words. Now, feature that you need to the feature that you need to extract is that convert the text data into numerical features that machine can understand. this could involve techniques like several techniques that can be with the frequency, several techniques. I am not going into the details, you can do that. They, mainly that feature of the emails that which suppose you have the data which is spam ham, whichever it is written and the email content is there. Based on that, you need to learn, you need to assign some parameter, that is your feature. Okay. So, corresponding to some feature, you will say that, oh, this I will assign this feature with a numeric and connect that with a numerical feature, and that feature it can extract from the email. Now, you have idea that maybe 0 means spam and 1 means ham. Okay. So, with by reading the email, somehow it will see the it will extract some features, like maybe there is no advertisement in the mail, then it is ham, that means not spam. And if there is advertisement somewhere, then it is a spam. On the basis of these features, it will note that this is 0, this is 1, this is 0, this is 1. Okay. Now, it will assign that, it note that. Now, you need to select a model, and model selection is that choosing of the classification algorithm. Common choices include like logistic regression, naive Bayes, support vector machines, decision trees, random forest neural networks, several KNN, and all the other model that you already are aware about these models. And maybe we are going to the logistic regression, KNN, these are already discussed in the lectures with you. I will show the codes that how you can get those codes and all of them also in the last part of the class, but now focus on this. So, this is the model selection. So, first feature extraction, then model selection. Then split the data set into training and test data. The training set is used to train the model, and testing set is used to evaluate its performance. Train the chosen classification model using the training data. Okay. Now, you need to evaluate the model. Evaluate the model's performance using matrices such as accuracy, precision, recall, F1 score, confusion matrix on the testing data, and adjust model parameters and features to improve performance if necessary. That is a continuous process, because data is going to change on the day by day basis. That is your daily to daily basis learning of your machine. Okay. So, first you need to select, you need to extract the feature, then you need to select the then you need to select the model, then you need to evaluate the model, and after that, once satisfied with the model's performance, deploy it to make predictions on new or unseen emails. When a new email comes in, progress its text, extract features, and use the trained model to predict whether it's spam or ham. And ongoing monitoring and maintenance is necessary, that as I am saying that on the daily basis, as the days will evolve, years will evolve, spam, the quality of spam or spam mails or features of spam mails will be different, and you need to continuous mode, in the continuous mode you need to learn that, you need to teach that to your machine such that it can learn that. Okay. Continuous monitoring and models performance on real world data is what we are expecting here, and there are some real world data that is given by Python for Python user itself. From the Python you can use, and for learning purpose, first what we will do, we will decide some own data which has no meaning. I will just give you that data to you, like whatever it is, maybe I will show it to you. So, based on that I will show the process that what you need to do. Okay. So, so this case study illustration, I hope this is clear now. The case study illustrate how classification is applied to a real world problem. That is the main thing, and the steps involved is data processing, feature extraction, model selection, training, evaluation, deployment, and ongoing maintenance. Is this clear? I hope it is clear. Like the case study illustrates, I will again mention this thing, that the case study illustrates how classification is applied to a real world problem, and the steps it involves is the data processing, that means the understanding, go through the data which we have already learned in the second and third week. Then extract the features that you have also learned. Then model selection, which you have learned in your fourth week lectures, and you also in this class. And then after that model selection, you need to go train the data, evaluate the data, deploy the data, and do the, and then further you need to do the maintenance of the ongoing data. Okay. So these are the main steps that you need to follow. And remember that different classification algorithms might perform differently on different data sets, and the choice of algorithm depends on the nature of the data and the specific problem that you are trying to solve. So this is a whole text that is given to you. You just go through this. I hope with this you can understand what is case study, what is classification, and what are the models, like what you can use, what you can do, what are the steps that you need to follow. Okay. Fine. So now I will go to the I just give me 1 minute, then I will go to this thing. Just recapitulate whatever I have told to you till now. Just try to process that in your brain, and then we will go to this process, okay, with the code in 1 minute. Okay, so here you can see that I am importing the NumPy. That is very universal, and we have already discussed lot of things about NumPy. Then I am also importing train test split from the sklearn.model selection. You need to import these also. If you don't have this, then you need to do you need to install this sklearn.model selection. But those who are using Colab or something all internet based Python, I don't think that there will be any problem. And then you need to import then you need to import logistic regression by from the sklearn.linear model. And to calculate the accuracy score, which was the one of the last steps in the case study, you need to do it from sklearn.matrices. Okay. So you need to install all this sklearn. You need to install sklearn by sudo install sklearn or whatever. You can search it on the Google, and then after importing this, after installing this sklearn, you need to import train test split from sklearn.model selection, logistic regression from sklearn.linear model, and accuracy score from sklearn.matrices. Now I am making a sample data set of weights in grams and color in binary thing, that is 0 and 1. If it is 0, then it is red. If it is orange, then it is 1. Okay. So 0 and 1. And what does it means? That 0 means red, red means apple, you can consider, and 1 means orange, that means it's a orange. So I am deciding, I am like this is a random data that I am making just to give you the glimpse and help you to understand the process. So this is a data, suppose, where I have defined an array of weights and colors. I have told 100 grams 0, 130 grams 0, 135 1, 151. Okay, gram, weights and colors are given there. Now I will label them with respect to 0 and 1, because this is very because this is a very easy data, that is why I can label them very easily with respect to 0 and 1. If it is 0 then it is something, and if it is 1 then it is something. This is a binary classification. Okay. So, let us first from very basic and these small examples you try, then you will be able to understand the like difficult ones much more easily. Okay. So, now you need to split the data into training data and testing data. Whatever data I have given, from that only it will train itself from, let us suppose 2 or 3 data of from here, and it will test the another one. This is very small data set, so the ratio will not be good for training and testing, and the model may fail also, but this is just to make you understand. So, in this if you use this train test split from the sklearn dot model selection, then the output that it gives is training of x, training of testing of x, and then y, training of y, and testing of y. Okay. X train means the first element of the first element of the 2D array, like the column wise, and the y means the second column. The x means the first column and y means the second column, like that. So, x train, x test, y train, and y test, that will be your output if you utilize this train test split. And in this, inside this train test split, you need to give your data and the labels that I have defined with respect to the color. And this test size is 0.2 by 0.22 approximately. If you do not have any other information, you can just utilize 0.22 as test size, that is the standard thing. If you do not give any test size, then it will automatically take 0.22. That means it will just test on 20% of the data, and other 80% data it will take to train the data. Okay. And the random state is equal to 42, means it will shuffle the data for 42 times and then it will choose. Okay. So, this is also, if you do not give any random state, then it will take automatically this this random state equal to 42. So, I am giving you the standard numbers which it will automatically take if you do not give any test size and random state. So, now you have train data and test data from this data set itself. Now, you need to choose a model. So, I am choosing model logistic regression, which I have imported from sklearn.linear model. Then I will train the model on the training data. For that, what I will do, the logistic regression I have considered as model, and then I am writing model.fit, and I am fitting, I am training the training the machine to learn with respect to the logistic regression model from the train data of the given data. Okay. So, x train, y train you have already got, train data which the logistic regression model is used to use for training purpose. So, for that the training for training purpose, you need to write this code, that model.fit x train y train. Now, you need to predict, and of course, prediction will be on the test data. So, the train the model make the prediction on the testing data, and I am writing it as in the like storing it as prediction, and then writing model.predict equal in the x test. And then you will need to calculate the accuracy, that how accurate your model is. Then then for that I will use accuracy score from the sklearn.matrices. There you can see I am calculating accuracy score on the basis of the y test and the prediction. Prediction come from the x test, and y test is already calculated based on the data. Now, I will check the what is the test data, y test actually it should be, that is the y test, and what the prediction it has made, and the similarity condition is checked by accuracy score. Okay. Now if y test is now if the prediction is very close to y test, that means your model is perfect. Like if it is 100%, then it is perfect. If it is 80%, then it is good enough. If it is less than that, then it one after another it will starts to it will show you as a very bad model. So you need to calculate the accuracy score for that, to know that if your accuracy of the model is good enough or not. So then after that you need to print the accuracy. I am printing I am printing in terms of by multiplying the multiplying 100 such that it gives in percentage value. So it will print the accuracy. So what you have done, so you I will go through the simple model once again. I have some dummy data which I have provided to you, which has no like no real life, this is not a real life data. Just to understand the process, I have given that to you. Then you are training the data and by utilizing the train test spreads, and also choosing that what data should be testing data. And based on so you have already stored that in x train x test, y train y test. Now you are choosing a model which is logistic regression here. Then you are fitting that model for the training data to learn to help learning to your machine. And then you are predicting that what from x data, the x test, that what can be your y test, and then you are checking that how close your y test is with your prediction, and printing that. If I run this, then you can see the accuracy will show 0%, because this is not a real life data and I have not given this data based on anything. So this is a very bad data as well as very bad model to do. So but this is the process that you need to follow no matter whatever data you have. Okay. So still now it is running, let it run, it will show you 0%. Okay. So we will come with the better data with real life data also, but before that you need to learn the process, which is this. So what was the thing that we needed to go through? We needed to go through the main that the case study. I will go through this point again, that the case study illustrated how classification is applied to real world problem, and the main steps involving involves are data processing, feature extraction, model selection, training, evaluation, deployment, and ongoing maintenance. Ongoing maintenance I am not showing because I am not doing anything with the real life data, and ongoing maintenance has several other problems. So we are not going to discuss about ongoing maintenance at this moment. So to know that what was your actually train data, test data, and in x and y from this data, given data, you can actually print the data, as well as you can print the x train data, y train data, x test data, and y test data. So I will just print it there, and you can understand the printing. I am doing this print because you can understand that what was your data, and what this model, what part of the data it has taken as train, and what part of the data it has taken taken as testing, model testing. Okay. As a testing data. So fine. So from that you can see that this is your total data. It has taken this one and it has randomized or shuffle 42 times. Then whatever it has got, that is it is taking as train data. It has got 151 and that is 151, 100, 0 and 135 1 as a training data, and y train is 101 corresponding to this 4. Now x test is it has taken test data as 130 and 0, that means this thing, and the y test is 0 from one of these two. Okay. So one data is has taken as as test from the data, and the other it has utilized for train, because I had just given 20% use, because you had the 4 data points, from that 80% it is using for training and 20% it is using for testing. Now also you can learn that what this train test split do to decide this, and how you can command that. For that I have also told you earlier that write that command and give a question mark, then it will give you the help about to learn what is this. Okay. So you can go and check anytime. So, what we have done in this example, we have simple data set with weight and color of fruits has features and corresponding levels. Feature is the weight and the color are the corresponding level with which I have decided the levels as 0 or 1. Then this was the first step. Then we have splitted the data set into training and testing sets using train, test, split. Then we have created a logistic regression model and trained it using the training data. Then we make prediction on the testing data and calculate the accuracy using accuracy score. That is what we have done in this example. I will share this with you, so no need to worry, you can play with these things. Okay. So, fine. Now, I will go to the next data, which is a real life data. This is a iris data which you can load from the Python. Okay, so before going to this data, this big data and real life data, I would like that you go through this thing once, this code once, and try to learn what I have done. In 2 minutes, I will start the next thing. I don't want to be fast at this moment because this is what you need to learn. Okay. Okay, fine. So, now we will go to this iris data set which I was talking about. So, of course, the train, test, split and if you are using logistic regression or the random forest classifier, whatever, that you also need to import. At this earlier I used the logistic regression which I have imported from the sklearn.linear model. Now, I will show this iris model with the random forest classifier which you can import from the sklearn.ensemble. Fine. Now, and the other things are same apart from this load IDs, because I need to load these IDs data sklearn.data sets, which is this IDs data is very famous data which is available to all of the Python users, and this is kind of hello world printing kind of thing, because this is the basic data set that every data scientist or data person whoever has started the career with data science and machine learning, they used to practice with this with the ML algorithms in the with this famous data set. Okay. So, this what this iris data set about, this iris is a flowering plant, and the researchers have measured various features of these different iris flowers and recorded it digitally. And there are 5 columns in this data set. One is the petal length, another is the petal width, another is the sepal length and sepal width and species. Okay. So, these are this is your IDs data set, that is what it contains. Okay. So, you can now what so I do not need to know much about the data, but still I can do this model. Okay. And as I am using the data from a real world, and this is supposed to be very good data, this IDs this data whatever IDs data, it is actually very good data. So, you will see that the accuracy it will get is 100%. I do not need to open the IDs data, I do not need to learn many things about the data, but still you can do the case study, you can do the classification. So, I have loaded the IDs data and given and allotted the variable as IDs, and then features are I have given features as IDs dot data and IDs dot target as the labels. Okay. We can print all of those things, that what are those things. Then you can split the data into training and testing data sets, which is xtrain, xtest, ytrain, ytest, and again 20% of the data it will take as testing data and 80% data it will take as training purpose. So, create a random forest classifier, I mean create a choose a model. Here I am choosing random forest classifier as a model, and then sorry, and then I am fitting it with this model by doing model dot fit extend ytrn and making prediction on the testing data by taking x data and calculating and checking the accuracy score between y test and prediction. So, if you do this, let it run. So, if you choose this, then you can see that it has run and it is showing that accuracy is 100%, because this is a very real life data. So, what we are using what we are doing here, we are using the iris data set, which has a more complex features. We are using random forest classifier, which is an ensemble method that can capture complex relationship in the data. Then we are splitting the dataset into training and testing dataset using train test split. We train the model on the training data and predict the levels on the testing data, and we calculate the accuracy using accuracy score. And each and every after that also I have defined why I have imported an NumPy, why sklearn dataset, what sklearn model selection, matrices, ensemble, what are those, and what are the what I have taken and why I have taken. Each discussion, each I have given as a text in this code. I will upload this and you can go through it. So, I have tried my best such that you are able to learn the case studies, and please utilize these things to learn them. Okay. So, now again I will go with some linear regression, because here I am showing several things like logistic regression, one another is random forest classifier from where you can import them, those all information are here. Now, I will go to the linear regression with some other data set which I have also created by myself, and then I will show you another data which is Boston data, which is also open source and open data that you can utilize by whoever is Python user. They can get the access of that and load that data and learn that. Okay. So, this is a case study method that I am showing, but there was one thing told here, that ongoing monitoring, that I am not going to do that at this moment, because I do not have any changing continuous variable data at this moment. But apart from that also, there is one thing that was given, is that data processing, data preprocessing, which for data preprocessing there were already two like in the previous class, in the previous week we have already discussed about the previous and the last part of the week 2 also we have talked about data preprocessing, that how you can do that like I have given the examples of failed student calculation, average number calculation, all of those things are coming in in the scene of data preprocessing. So, I am not going there. After doing the data preprocessing and feature extraction, which can be different thing in case of different data, and then after that what you need to do for doing the case study, that is what is purpose for today's class, which I am doing here. Okay. Okay, fine. One more thing I can show, that features and levels that I have calculated here for the iris data, I can print that what are these, but it is not a good idea to printing, because these are loads of data like you can see it will. Yes, so these are the x data that x that he has taken as features from the iris data, iris dot data, and from the target if you print the target, if you print the y, then it will say that labels. Okay. So, choosing the features and levels and pre-processing of the data, that I have not shown, as it is already discussed in great detail in the lectures also. So, after that what is the case study, that is what I am showing. Okay, fine. So, these are all the details that you can see, that what I have used, that the details of the sklearn data set, model selection, and iris data, the discussion of that, everything is given. You can take 1 or 2 minutes to read this part, and I am not going through it because this is already written, and this will also be shared with you. And then I will go to another thing, that is a linear regression, and so with some other toy model data, which I will just give you, and then I will go to the Boston data. After showing all of them, then we will go to something else. Okay. So, again 1 minute rest and process your mind for this thing. And I hope you have already understood what is the thing that you need to learn with for the case study. It is already discussed in the great details and till now, but still I will again come with the next I with 1 minute I will just give you for the processing in your brain, and then I will again start the next part, next problem, next example. Okay. Okay, fine. So next I will not discuss so much. First thing that earlier I have discussed about the logistic regression and the random forest classification. Now I am importing linear regression from the linear model, scalar linear model again. And now for the matrices, till now I have used the accuracy score by importing it from the scalar dot matrices. Now also you can, without doing accuracy score, you can also do mean square score and R2 score, which you have also seen in your lectures, that mainly mean square error and R2 score, those are used in this case study calculation, accuracy calculations. Okay. So again I have decided a sample data set which is the mileage in miles and age in years and brand. Brand is, if it is 0 then it is Toyota, if it is 1 then it is Honda. Okay. Just an exemplary data. And the price is given to you, which I will use as labels. Okay. And sorry, and also the price is given to you, and the labels are already of course here I am using prices as a labels, but maybe you can use 0101 this brand also as a labels. That is also good levels, but here I am using labels, prices as levels, because I want to show the multi-class classification. Okay. So this is a multi-class classification on the basis. Okay, let me add. Okay, fine. So this is the data. These are the prices on which I am leveling, and then I am again splitting the data into training and testing data by using train test split and giving the data. Labels is my prices, and again test size is 0.2. 20% it will take as data testing data, and other 80% it will take as the training data, training purpose, and random state is 42. It will shuffle by 42 times, and then it will create then it is taking the linear regression as a model, and then it is training the model on the training data by doing model dot fit, and then it is predicting over a x test, and then you can, then now you need to calculate mean square error or r squared. And for that you have imported mean square error and R2 score from the scalar dot matrices. You just need to use that mean squared error and in the bracket y test and prediction, because what is accuracy between y test and prediction, that is what you needed to check. Earlier you were using accuracy score, now you are using mean squared error or R2 score. Now you can print them. So as this I have given this data, like this is a random data, so it is showing mean square error as 81,000, R2 square, R square as nan. So these are not real values, because this is a not real data, I have just randomly given it. Okay, so what we have done, a simplest data set of the mileage, age and brand as a feature and corresponding prices of used cars, and then we split the data set into training and testing data using train test split, and we create a linear regression model and train it using training data, and we make prediction on the testing data and calculate mean square error and R2 square error using mean R square error. Okay. So this was the thing. So these are the several example with the linear regression, and there can be several accuracy score also. Okay. So So now I hope you can understand that what is the thing that you need to that you need to do in case of case study. Okay. So now I will go to the Boston data, which is the Boston housing data set, which is another open source open set of data that Python users can utilize to learn the several machine learning algorithms. And this Boston housing data set is used mostly for mostly with this 1 minute mostly with the linear regression and any regression analysis, and they here also in this Boston data set also it consists of complex complex data quality, and with the help of the linear regression you can like what I can say, this data set has been a staple for algorithm demonstration. Actually, people are using this to learn them, and more from simple linear regression to more complex machine learning models in this analysis. You can do whatever you want to do with this kind of data. Okay, this data is a very nice data actually. So this Boston housing data set is a collection of data from 1970s on housing prices in various Boston districts commonly used in machine learning to demonstrate this kind of regression analysis. So this was originally curated by US Census Service. It includes 506 instances, each with 13 features, and the target variable is the median value of owner occupied homes in the $1,000, like it is given with the unit is in the $1,000. Okay. So fine. So there are lots of information in this data. So this is a very nice thing to for learning to utilize this data set for learning for the hands-on sessions. And again here I am nothing doing anything extra, because I just want to give you the glimpses or the idea of case study. So here also I am loading the Boston data, I am doing deciding the features and prices I am taking as target, and which I will use as levels, and then I will this part for this thing actually you need to go to the pre-processing of the data which was discussed. Now I am just taking a simple things as features and levels. I am not going on these details because those discussion were already done in the previous 2 weeks. But after that what you need to do, again the train, test, split and linear regression I am using, fitting, prediction and calculating the mean square error and R2 square. Okay. So now if you calculate this, sorry, I don't know what is happening. Okay, so I don't know what is the problem at this moment. It is showing some problem is there in the loading. I don't know. Earlier it ran actually. Okay, so that is not the problem, but you can see that you can just load this kind of data and do the case study and learn about the starts, like how to do the basic case study by doing the classification problems and all this by utilizing this linear regression and all those models. So every details of this training, testing and whatever I am using, what are the detailed process, everything is again given here. But one thing that while I am doing this thing, there can be some. So these are the process that what are the steps involved in the implementing linear regression. That is again given to you. That data preparation, model creation, model training, prediction, evaluation, interpretation, prediction, and generalization, which I have already mentioned. This I have again written for you such that you can go and learn it again and again, see it again and again, and go through it again and again. So, but there are some assumptions which we are taking when we are doing the linear regression. This part is not discussed in anywhere, but I thought it is necessary to know that these are limited models, like it is not nothing is universal. So, what are the assumptions that we are taking while we are doing the linear regression? So, we are taking the assumption of linearity, that the relationship between the input features and the target variables should be approximately linear. Okay. We are also considering while doing this the independence, that the errors or the residuals should be independent of each other, that there is no correlation between the there is no correlation between the errors. Then we are also considering the variance of the error should be roughly constant across all levels of the target variable, okay, which we call as homogeneity. So this is another thing that we are assuming. And another fourth thing is the normality, that is the error should be normally distributed, kind of Gaussian distribution. Okay, so these are the four assumptions we are taking while whenever you are doing the linear regression. These details are not provided anywhere, but these are the decision automatically you are taking whenever you are using this kind of linear regression method, doing the linear regression. So these are embedded in it. Okay, so remember that while linear regression is a powerful and widely used algorithm, it might not be suitable for all types of data and relationships. In some cases, more complex algorithms like polynomial regression, decision trees and neural networks might be needed to capture nonlinear relationship in the data, because linear regression will not catch them, it will just do the it will automatically consider the assumption of linearity, and it will just approximately everything, the input features and target variable, it will approximate as linear relationship. So of course this is not a very powerful algorithm. Okay, so so these are the features that linear regression has, and this is the process where when we do the case study, how to do, how to use the linear regression, how to import them, how to mainly what are the main problems that you can solve with this, how to do the case study, what are the steps that you need to follow, everything is given here, and that this is very important for your this week's content. Okay, so I'll stop presenting this, and then I will go to the KNN and the models. The codes are also shared with you. I'll just show that I'll just show that how you can access these codes, and because these you can access and you can learn to how to utilize this. First maybe I will present what I am talking about is this one. Okay, so you can see there are so again these are some like which I have shown. I have again imported the several things I have in this code in this NPTEL week 4.5, which I will share with you. There I have given all of the importing modules that you need to import for doing the whole analysis from the beginning to end. For that you need to import pandas to work with the data frames, then you need to numpy as NP for performing numerical operation. To visualize data you can use Seaborn, you can of course import matplotlib.pyplot to plot several other things. For the partitioning of the data you need to import trend test split by doing from the sklearn model selection, then importing library for logistic regression, you can do it from sklearn.linear model, and there are several other KNN is there, which is K-neighbor classifier, that you can do from the sklearn.neighbors, and from sklearn.matrices you can import accuracy score, confusion matrix, R squared thing, and several other things for checking the accuracy. Okay, so here there is another set of data, service states.csv, which I will give, of course, which again I will provide it to you. You can check, you can play with it, and this is another set of data which is doing the same thing. Here also I am, but here it is the checking the data preprocessing part is also given for this service state.csv. Okay, so here I can just run it once, and you can see that several things are printing, because I am printing the data, I am printing the columns list, features, and every other thing. So then basically what I am supposed to say that this is a code which is NPTEL by underscore week 4.5, which is written by me, which I will provide to you, where the from the starting data preprocessing to today's class, which is a case study, everything is given there. Okay, so this is the same thing. Pre-processing part is already told to you in the previous 2 weeks, and case study part I am doing it for the past 1 hour in great details. So those codes, those are, previous codes were for learning the case study, what is the main scenario that you need to follow, what is the main steps that you need to follow. Now after here it is a total code where you can do the same thing. For that I have a service state or CSV file. From that I am doing the data preprocessing, I am doing the other part, model prediction, model analysis, and all of them, and checking the accuracy score and everything. Okay, so I will not go in details of this. And okay, so here there is knn.py, which is written by Gita, that is the like from the that whatever the videos that you are used to see, from there only I have taken these knn.py, regression case study.py, and the logistic regression.py. Okay, all of these codes are like total code where the pre-processing, classification, import, everything, full analysis of a data is given to you, which is also discussed with you in your class, in your lecture videos in great details. So again I can show you once that how you can access it from my, from the Google Drive also. I will upload this, but it is also presented in the it is also presented, the information is also given in your SWAM portal also. Okay, so I hope the whatever she has shown it for the knn.py regression case study and logistic regression, you have understood it in great details, because those were very rigorous lectures. And the short version of them, how, what is case study and how we can do that, I have shown you today just to learning purpose, because you need to do the hands on session and learn whatever and learn what exactly you have learned, because these are big data, these are the real life data, these are the like these there are much more details contained in it. Okay, so I will encourage to play with these things. Fine, so these are the things that I wanted to do, and now I'll go to the assignments as I do every time. And after going to the assignments, after discussing them very quickly, I'll just show you the syllabus, that what was our aim and what we have completed, and mm, uh, then we'll conclude the this semester's Python for data science course. Okay, fine. So now I'll open the chat section for you. You can send chat and tell that what are the answers, what I do every other time also. So this is your first question from today's assignment. Okay, so what it is telling, it is telling which of the following are regression problems, assume that appropriate data is given. I have already given a great detail of introduction for regression problems. I hope you have understood them. So try to answer this question one. It was, what is your question? Write in the chat box. How to answer in chat? In the chat box you can just write that question one, what are the answer, A B C or B C D or C or A, whatever it is, just answer. Excuse me. So So, it is saying which of the following are one. Okay. So, it is saying which of the following are regression problems. Assume that appropriate data is given. So, someone is saying A, then someone is saying 1, 3, 4, someone is saying A. Okay. Whoever is saying 1, 3, 4, that is the correct answer. The predicting the house price, predicting the maximum temperature on a given day, and predicting the sales of ice creams, all of them are the regression problems. Predicting whether it will rain or not rain on a given day, that is not a regression problem, that is a binary classification problem. Okay. So, regression problem are for continuous variables like house price, maximum temperature, sales of ice cream, that depends on the day to day variable. These are continuous variables, and that's why these three will be the answers, that for all of these three things you can utilize the regression problem. Yes, Irani, you are correct. Also predicting sales of ice cream. Okay, fine. And Prabha, you are also correct. Which of the following are binary classification problems? Number one, okay, I have to change the slide. Which of the following are binary classification problem? One is predicting whether a patient is diagnosed with cancer or not, predicting whether a team will win a tournament or not, predicting the price of a second hand car, classify web text into one of the following categories: sports, entertainment, or technology. So, which of these four are binary classification problems? Yes, so whoever has given the answer 1 and 2, that is correct. That predicting whether a patient is diagnosed with cancer or not, it is a binary classification problem. Predicting whether a team will win or not, that is won the tournament or not, that is also a classification problem. And the other, which are the three, whichever which is the fourth one, that is a multi-class problem, and the predicting a price of second hand card, that is a that is also not a binary classification problem, that is the impedance classification actually, imbalanced classification actually. uh, mm, uh, and then we can go to the next question, that is a 3. So the question 2 has a answer 1 and 2 then. Okay, predicting of cancer and the predicting of winning a tournament. Now the 3, if a linear regression model achieves zero training error, can we say that all the data points lie on a hyperplane in the d plus 1 minus d plus 1 dimensional space? Here d is the number of features. Maybe for this you can go to the go to your lectures, there it is there it is discussed. Okay, so the to clarification for Irani's question, that in a d plus one dimensional space, a hyperplane is a subspace with dimension d, meaning it is essentially a flat surface. In if you go for the three dimensional case, what is your question actually? So the dimension is a hyperplane in a d plus one dimensional has a dimension of d. That means in a 2D space a hyperplane is a line, that is 1D, one dimensional. In a 3D space a hyperplane is a plane, that is two dimension, and in a d plus one dimensional space the hyperplane is a d dimensional subspace. Okay, and this hyperplane is a generalization of a two dimensional plane in a three dimensional space in mathematical spaces for an arbitrary dimension, and this is in case of geometry. Okay. Okay, so everyone is saying yes, and this is correct. Now I will go to the next question. So there is given a data description for next questions. It is saying an automotive service chain is launching its new grand service station this weekend. They offer to service a wide variety of cars. The, the current capacity of the station is to check 315 cars thoroughly per day. As an inaugural offer, they claim to freely check all cars that arrive on their launch day and report whether they need servicing or not. Unexpectedly, they get 450 cars. The serviceman will not work longer than the working hours, but the data analysts have to. Can you save the day for the new service station? How can a data scientist save the day for them? He has been given a dataset servicetrain.csv, which I was showing few time ago, that contains some attributes of the car that can be easily measured, and a conclusion that if a service is needed or not. Now for the cars they cannot check in detail, they measure those attributes and store them in this CSV file. Now based on that, which they are saying that which of the following machine learning techniques would not be appropriate to solve the problem given in the problem statement. I will go to the problem statement. You can think actually about it. It is not hurry. I can give you the answer, but it is good that if you check the if you check it with check the questions later on. The next question I will also go. Next question is saying that after applying logistic regression, what is or are the correct observation from the resultant confusion matrix? I will give you the code, you can check that. You cannot predict it without running the code actually. So question 4, 5 and these 6, all of them, the code also I will provide. The question the you can check and see what are the values that you are getting, because without knowing the data you cannot give the answer of them. Okay, so for the this is my, for 4, 5, 6 I will give you the code also. You have the data also, you will have the data also, you can check it and do it peacefully in later time. Okay, so I will not go to this go to this 4, 5, 6 question. Now I can go to the some other questions which do not need any other information. So you can answer this question, but for 4, 5, 6 is your homework, which you can do after getting the code and data and after checking them. Okay, so I am not forcing at this moment. It is not it is not the correct. Okay, it is not the correct approach because you do not have the data at this moment. So the question now it is saying in question 7 is that how are categorical variables preprocessed before model building? This also was mentioned in your lecture, so I hope this can be this you can give the answer. So how are categorical variables processed before model building? What are the answers? Okay, so people are answering dummy variables. Yes, correct. The answer is B, dummy variables. Now, question 9, it is saying a regression model with the following function y equal to 60 plus 5.2x was built to understand the impact of humidity and rainfall. Humidity is x and rainfall is y based on the linear based on uh, like the function that you have that is given to you. Now, the humidity this week is 30 more is 30 more than the previous week. What is the predicted difference in rainfall? So, the function is already given to you, so it is not a problem to calculate, so you can just do that. This is a very easy problem. Think once again, this is very easy problem, that a regression model with the following function was built to understand the impact of humidity and rainfall. The humidity this week is 30 more than the previous week. Now, you need to predict the difference in rainfall. Difference. Be careful. Okay, so whoever has given the answer as A, that is the correct answer, 156 mm. Now, why? Because you need to calculate the difference that was predicted and that you have the difference between the predicted like what you have predicted and what you have got. Okay, that you need to calculate. Now, the that 5 the it the humidity of this week was 30 more than the previous week. Okay, so suppose you have some in the previous week you had humidity was something m. So m, so this week so you m, and this week you predicted that this will be n, but what you have got is n plus 30. So earlier you predicted y equal to 60 plus 5.2 into m, because x equal to m as the humidity, and this week you predicted 60 plus 5.2 into n. Okay, now you have got 60 plus 5.2 into n plus 30. So what you have the difference will be, as it is a linear regression, the value is like it is following the condition or assumption of linearity. So if you do the difference, then the difference will only be the 5.2 in times the 30. That is the extra part, that is the difference part that was not predicted earlier, but you have got. So that is your difference in the prediction. So just 5.2 multiplied with the 30, that is the 156 mm, which is the answer. That is a predicted difference. Okay. Yes. Now the next question. It is saying that x and y are two variables that have a strong linear relationship. Which of the following statements are incorrect? There cannot, the options are, there cannot be a negative relationship between two variables. The relationship between the two variables is purely causal. One variable may or may not cause a change in the other variable, and the variables can be positively or negatively correlated with each other. So whoever has given the answer 1 and 2 or A and B, like there cannot be a negative relationship between the two variables, and the relationship between the two variables is purely causal, those two are correct answer. Okay. So those two are correct answer. So now we have discussed all of the assignment problems. Now there is not much left here. First I first need to go to the syllabus, that what is the syllabus that we wanted to discuss here, and then I will go to the that what we have and I will simultaneously say that extra what extra you need to So data set are not available. No, data set, every data set I have provided in the Google Drive folder. So no need to worry. And whatever I am showing for today's content, that will be also updated and uploaded by tonight. Okay. So no need to worry. All the data set you will get. Now I will go to the syllabus once. Give the drive link. Okay, I will give the drive link once again. And in the finalization, will we have to access the files in IDE to do the same, especially for data set or the question. Data for the data set question, some question you no need to take any help of the IDE or any module, any interface to do the codes, to run the codes, but for the data set which you really need to check with by running the codes, for that purpose the ID will be there, what I know, but I cannot like this is the this discussion is still is not, I am not very much clear about that. So that will be updated to you by the email before your before your examination. Okay. Share copy link. Okay, no, sorry. Okay. So I'll share the I'll share the Google Drive link once again. So this is the Google Drive link. I will pin it. You can go to the Google thing. You can go to the YouTube also for the recorded lectures. The admit card for the exam will everything will be prior. It will all the emails will go very in advance to you. No need to worry about that. So the dates actually I have forgotten. I do not remember exactly. The dates are given already, I guess. Let me check. But if I find the mail, then it's fine. If I could not find, then you I can assure that you will get way in well advance, so you no need to worry about the things. And the syllabus, now I will go to the syllabus for giving you the thing, give you in the glimpse of what you have understood and what you have gone through till now. So this course was run by Professor Raghunathan Rangasamy, and I was your TA Nilakshi Senapati for this course. And our main code, I mean the aim was to learn basic Python as well as to learn how to handle data with the Python. We have to we learned about pre-processing the data. We have learned about the various case study, various models, linear regression, and so on. And uh, uh, this is the actual syllabus that we have in this course. Week 1 we have basics of Python Spider. We have Python. We have learned introduce you with the like how to install the Anaconda, how to install how to open Spider, how to set the working directory, how to work with the uh, like Jupyter, Colab, everything I have shown. Then after that, how to do the file execution, clearing console, removing variables, and variable creation, arithmetic, logic operator, data types, associated operations. All of those are discussed in week 1. In week 2, we have discussed about sequence, data types, and associated operations like strings, list, arrays, tuples, dictionary, sets, range, etc. Then we also discussed about NumPy and pandas in that week. Then we went to the week 3. We have discussed about pandas, data frame related operation in different data set, data set, and we have read the file. We have exploratory data analysis. We have done the preparation of the data, pre-processing of the data, plotted the data, visualized the data. We have done the scatter plot, line plot, bar plot, histogram plot, box plot, pair plot, all of them. We have also learned about if else family, for loop, while loop, for loop with break functions. All of them also I have gone through in the I have shown it to you in the previous class. And then last in this class, in this week, it was about case study. We have done the regression, predict and classification. We have done the we have learned how, what are the basic steps that you need to follow to do the basic analysis of the data, or to do the basic case study. And uh, for all of this register, okay, great, we have all of you, I wish you best of luck for your examination, whoever has registered for the examination, and hope you will perform the best on that day. And mm, uh, whatever the about the address of the examination city, admit card details, all of them will be given to you on in an advance, uh, well advance before the deadline or before the examination. So you don't need to worry about that. You just prepare yourself for the examination and all of these things. I and other things will be the other things will be aligned, and other things will be done by NPTEL very nicely, and they conduct examination on every single semester. And the processes are also very nice. If any like if any city has any problem with in that particular date or time, that also they shift. So no need to worry, but the time will not be shift, date will not be shift, those are fixed. Those those and okay, gh1 report.csv, ghi report.csv, that is not given in the drive till now. I will upload whatever I am showing in today's class, and the extra things which are for week 4, that I actually upload after the class, so no need to worry about that. And the question pattern, I think mostly this whatever type of question that you are getting in the assignment, quizzes, and in this live sessions, that type of question you will get. And the so you do not need to have any prerequisite about ML, that the prerequisite is written, but I think I have gone through from the very basic of Python, from installing to like utilizing for the basic, how to do the basic numerical operation, how to do write a code, and everything I have gone through in each in very great details. So in the first week, that's why many people get bored also, because of the very naive introduction to Python. But those were needed, and I actually like that whoever has no introduction, no prerequisite about the data science and machine learning and all of those things, they can also do write the examination, no need to worry. And you can learn just by 4 week with in these 4 weeks only. Okay. I was not able to submit the third assignment. Is there any way to submit it? So among the 4 assignment, you need to submit at least, I think, 3 assignment to get the certification. But if the deadline has crossed for the assignment 3, then there is no way that you can submit it again. Okay. So you need to maintain the deadline. You please, 1 2 you have submitted, I am hoping, and 4th also you need to submit, and a third one, if it is not done, then you can also manage, because out of 4, 3 needs to be submitted, and you need to get also the like well, good marks, and I have forgotten 75% something like that, to get the certification. Okay. So fine. So this was the syllabus, and I will stop presenting, and I will just conclude now for today's ma'am. Okay, my email ID, I can give you the email ID. Wait a minute. I will give you the email ID. So this is my email ID, nilakshi s22@iitk.ac.in. You can contact if you have any problem, and okay, fine. So this is the I will finally like to conclude this course. This is the Python for data science course for this semester by NPTEL. Um, Okay, so this was a Python for data science course by NPTEL under the supervision or instructed by Professor Raghunathan Rengasamy, and I am your TA. I was your TA for this course. I am Nilakshi Shanapati and from IIT Kanpur, and these were your discussion tutorial sessions where you get a chance to directly interact with us, as well as to do the hands-on session while I am doing. And so I hope you have enjoyed this 4 weeks classes and you have learned how to use Python, and uh, as well as how to use Python for data science. Okay, so now I'll stop it. Yes, this is the last class. There will not be any class anymore. So 25 for January we have started our journey. Today is the 15th February that we are stopping this journey. So uh, I hope everybody has enjoyed this course, and this is the last class, and all the best for your examination, and hope, hopefully that everyone will perform very well, and I will provide everything in the Google Drive. No need to worry about that. I'll upload them, and for any other information like for the recorded lectures and all of them, you will get in the uh, YouTube channel. Okay, so fine. Thank you all for joining the classes, and thank you for making it successful. Thank you, thank you, thank you. Bye, 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 everyone. Thank you, everyone, for joining and enjoying this class. Bye, bye, bye.